Okay, Algebra 2, Unit 3, Lesson 18 is called the quadratic formula and complex solutions. Goal today, I can find complex solutions to quadratic equations by using the quadratic formula. So we kind of jumped into this a little bit if you watched my 317 video. When we were finding how many real solutions we have, we kind of cheated and used the quadratic formula a little bit. Today we're going to go all the way to finding the actual solutions by using the quadratic formula. So a little bit further. All right, so mentally decide whether the solutions to each equation are real or not. So I'm not going to use quadratic formula here. I'm just going to kind of go back to what we were doing before, where we square root both sides. So if I square root, you obviously see we have a square root of a negative. And we need to have a plus or minus, actually. So W is going to equal plus or minus square root of 367i there. So we're going to have two non-real solutions. Okay. This here, you got to move the 25 over to the right. So I subtract 25 from both sides, square root. We're going to get x equals plus or minus square root of 25 is 5, and then the negative becomes I. So again, same thing, two non-real solutions, okay? Over here, square root. So since this is 0, we'll just get y plus 5 equals 0. So when I minus the 5, we're going to have one real solution. Okay, because it'll just be y equals negative 5. Over here, this is kind of just like the first one. You square root. So obviously, once I square root a negative, I'm going to have two non-real solutions. And I'm just going to stop. I'm not going to go all the way on that one and find the actual solutions, because it just says mentally decide whether they're real numbers or not. So obviously, once you got this negative under a radical, we know that there's no real solutions there. All right. So Kieran was using the quadratic formula to solve the equation. He wrote this. Okay. Solve what equation? All right. Well, they didn't give us the equation, but remember the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So basically, he plugged in the a, b, and c and got this. Okay, so I think b is going to be 12. Looks like a is 1. And then I don't know what c is. C is something. So he noticed that the number inside the square root is negative and said this equation doesn't have any solutions. Do you agree with Kieran? Explain your reasoning. Well, here's what I would say to Kieran here. I would say he is correct in saying that it doesn't have any real solutions. However, we will have non-real solutions, which we know are called complex. Because we can simplify the radical in terms of I. Okay, so basically, if I go up here and I set that, whoops, let's just simplify it here. We get 12 plus or minus the square root of negative 20 over 2. So, he got this negative under here and said, oh, it doesn't have any solutions, but it does. They're just not real. So we won't see them on the x-axis. All right, write the square root of negative 20 as an imaginary number. So again, this textbook kind of is weak in simplifying radicals. So you could write square root of 20i. That's good enough for our book. I would want you to simplify that under normal conditions. So you'd write 20 as with any factors of perfect squares. Since 4 is a perfect square, we want to rewrite 20 as 4 times 5, and then you square root the 4. and pull it out. So I'd get 2 times the square root of 5i. Okay. So either one of these, this is equivalent. It's just not simplified. This is better. You could even also type in square root of 20 on your calculator, and you're going to get 4.47. And this is another answer, but this is not as good because it's rounded. This is the best. It's a simplified radical. All right, so here we go. Let's solve this one. So it says plot the solutions on the complex plane. So remember, this is your I-axis, your BI axis, and this is your A axis. Real, imaginary. Okay, so I'm going to use quadratic formula here because it's in standard form. X equals negative B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. This is minus 600. All right, so now I got a little bit of simplifying to do here. I get 10 plus or minus the square root of negative 500 all over 6. So let's simplify this. This is going to be, let's do this first. Let's say square root of 500i. Let's get that negative out of there. And let's split up the denominator. You'll see why. So obviously we have two complex solutions here because I got the I. 10 over 6 is 5/3. 500 is really 5 times 100. And I chose these factors because 100 is a perfect square. So then I can take the square root of 100. So it's 10. And then I can reduce that. And my final answer here is going to be 5/3 plus and minus 5/3 radical 5i. So let me just double check my math here on this. Okay, I think I'm good. All right, so this is my A and this is my BI. So, I might want to make a decimal here. So A is 5/3, which is approximately 1.67. BI. So let's do this. 5/3 plus 5/3 times the square root of 5. And I got 5.39i. And then I'm going to do 5/3 minus 5/3 times the square root of 5. And see what you get here. I got negative 2.06i. Okay, so basically I'm gonna plot it like this: 1.67 plus 5.39i, and then I'm gonna do 1.67 minus 2.06i. That way I can plot the points a little bit better. So I go to the right 1.67 and I go up 5.39. There's my first one. And then I go to the right 1.67, I go down 2.06. right, and actually this one would probably be a little bit closer to the 2. There we go. So there are my 2 non-real solutions. All right, for each row, you and your partner will solve a quadratic equation. You should get the same answer. If you disagree, work to reach agreement. So these are the same exact equation. If you don't believe me, you could complete the square here to get it in this form. Or if I wanted to multiply this out and move everything over, I could. I'd get x squared minus 4x plus 4. If I want to make a box, minus 8. And you can see very quickly this equation is the same as that. Okay, so they're all going to be the same. So we're gonna solve these based off of how they're set up. Whoops. So this here, I'm going to start with this one. This is easiest. I'm going to square root both sides. So I'm going to get x minus 2 equals plus and minus square root of 8. Add 2 to both sides, 2 plus and minus the square root of 8. So I come over. Now, I got to simplify this radical, but I'll do it in a minute. So I'm going to come over here. This one's more set up for the quadratic formula. So I'm going to get x equals negative b. So negative 4 is positive 4. Negative 4 squared is 16 minus 4 times 1 times negative 4. So this is 4. Oh, I'm sorry, all over 2 times 1. So this is 4 plus or minus the square root of 32 all over 2. So you look at this and you're like, oh, they don't look the same. Well, that's because they're not simplified. So let's do this here. Let's split this up. 4 over 2 plus or minus square root of 32 over 2. And what I got to do is I got to say, okay, square root of 32 is really 16 times 2 over 2. Why did I choose those factors? Because 16 is a perfect square. Square root of 16 is 4. So I get 2 plus or minus 2 radical 2. So that's simplified. If I come over here, whoops, let me go back and use the same color. So 8 is 4 times 2. Take the square root of the 4 and pull it out. So the square root of 4 is 2. So I put on the outside. You end up getting the same numbers. Now, if you are weak at simplifying radicals, what you could do is you could type these into your calculator right here and get a decimal, and then you could type this into your calculator. That's a 3. It doesn't look like a 3, but there you go. You could type this into your calculator and get a decimal, and those two should be equal as well. That's another way to do it. This is better, though. All right. On to the next one. So this one, I'm going to use square roots. This is going to be square root of 8i. Add 2 to both sides, so I get y equals 2 plus or minus square root of 8i. Over here, you could go quadratic formula. So y equals negative b. So it'd be negative 4 plus or minus the square root of negative 4 squared 16 minus 4 times 1 times 12 all over 2 times 1. So here's where you get these numbers. They don't look like they match up, so we have to do some simplifying. So I'm going to make the negative an I. I rewrite the 32 as 16 times 2. I'm going to split up my denominator. Square root of 16 is 4. And then 4 over 2 is 2. So this is kind of just like the last one. Square root of 8 is 4 times 2. Square root of 4. So you get the same number for each of those. Okay. All right. So here's one that's a little bit harder. We have some fractions and we have a not equal to 1. So let's go ahead and let's try this. Square root both sides here. So I get z plus 3 halves equals plus or minus. Let's do this. Let's make the negative 29 up top in the radical. And then the square root of, let's put it up like this. It's like negative 29 over 4. So you take the square root of negative 29 over the square root of 4, and the square root of 4 is 2. So I don't put it under a radical there. Move the 3 halves over to the right, so it becomes negative. Let's rewrite this as square root of 29i over 2. And actually, this is actually a little bit easier because there's nothing to simplify. 29 is a prime number. So the only factors of 29 are 29 times 1. So there's no perfect squares that you can get out of there. So we're good. All right. So obviously I have 2 non-real solutions. So this one, before I can start firing out the quadratic formula, I got to move the 19 to the left. So be negative b. So negative 6 is positive 6. Negative 6 squared is 36. So we get here. So I get negative 116 all over 4. I'm going to split it up. All right, so they don't look like they match up, but let's see what we can do here. 116, is that divisible by anything? It's divisible by 4, so I could rewrite this as 4 times 29, make the negative an I, and let's put this over 4. So pull out the square root of 4. So I end up with so we got a little problem here. We look at these and we see that this is negative 3 halves and this is positive. So they almost look the same. So I gotta look here and see if I made a mistake or if I gotta move everything over the other side. Okay, so I was taking a little bit of a look at it there. I kind of paused the recording, and these are not equivalent. Now, the reason is because my slides had this sign here as negative. Now, you had it as positive in your book. So if it's positive there, that would change this to a negative. So here's what I'm going to do. I'm going to just change the sign so it matches what you have in your book. So that would make this positive right here, which this would be negative And this wouldn't change this because when you square 6 or you square -6, you still get the same thing. So that's what ends up happening here on this one. So then now we get them to match up. For whatever reason, my slides had a different number there than your book did, so we got them to match up when we had the right problem written down. So, all right, let's see. I'm going to just kind of skip through here on these last couple. I'm going to skip this one for the sake of time. We'll go to this one because this one's a little bit more challenging, and then we'll jump to the end. So, all right, so quadratic formula. So t equals -b square root of b squared minus 4 times a times c all over 2a. So I end up getting 20 plus or minus the square root of 0 over 8. So this is gone. So 20 over 8 reduces to 2.5 or 5/2. So one real solution here. Over here, I'll tell you what, the easiest way to do this is probably just to distribute. Because it's not squared, I can't square root both sides. And then if I move the 25 over by adding it to both sides, you're going to notice right away that we're not going to get the same number because this is positive and this is negative. If you look here, and let me check the book here. Oh, again, oh, I see what I did. I just made a little mistake here. I don't know why I made that a plus 20. So, all right. So once you get here, you see that everything is the same. If you look at your equations here, they're the same equation. So there's no point in redoing the quadratic formula. You're going to get the same value. T equals 5/2. Okay, so it worked. All right. So quadratic formula or completing the square y. This one I would complete the square y. Y, I would say, because a equals 1 and b is even. Okay. Same thing for the next one. I would say the same reason. Complete the square. B is even, a is 1. The next one, I'm probably going to go quadratic formula because b is odd. This one could go either way, really, depending on how good you are with your fractions and stuff. This one, definitely quadratic formula. And my reason on this one is a is not equal to 1 and b is odd. And this one is probably going to be same type of thing. Quadratic formula. A is not equal to 1. Okay. Anytime a is not equal to 1, quadratic formula is way easier. All right, so goal, I can find complex solutions to quadratic equations by using the quadratic formula. So last one here, let's solve this. So I'm going to use quadratic formula because a is not equal to 1. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So what do I get there? I get 4 times 3 times 4, negative 48. All right, so once I get here, I have to split this up so that it looks like a complex number. So square root of 23, can't simplify that. That's a prime number, so I leave it like that. So I have two complex numbers, okay? Two complex solutions. So on a graph, my graph will never touch the x-axis. All right, hope you enjoyed this video, and thank you for watching.